Okay. Hello. We're going to be doing the Gaussian integral today. So, the Gaussian integral is this. Negative infinity to infinity. Integral of e negative x squared in terms of x. Okay, so, oh goodness. Okay, so, how do we start? Well, we define this such as I. Now this actually isn't solvable on its own. Can you guys see that? Yeah, I guess you kind of can. The actual integral on its own isn't solvable. Instead, we're going to take it to 3 dimensions. To do that, we can actually say that the integral from infinity to infinity of e to the negative x squared dx is equal to integral of infinity to infinity e to the negative y squared dy. Therefore, we can say such that I squared, remember I is the Gaussian integral, I squared equal to these two squared, or multiplied by each other. So we multiply them by each other, and we get infinity to infinity. This is a double integral, which means it is in 3 dimensions. If I could write e to the negative x squared plus y squared dx dy. Now, what do we do from there? Well, we actually have to take this into something called cylindrical form. So there's something called polar form, which is basically Cartesian is the normal one, which is an x distance and a y distance. Polar is a distance from the center and an angle. Cylindrical is polar plus a z-axis. In this case, this is a function of z, so we're just changing x and y. Now, the way we actually do this is something called the Jacobian, but that's not important. This will basically go to infinity, oh no, double integral, infinity, not yet. Okay. Oh, whoops. It's already here. So, if you're wondering where this r came from, the x squared plus y squared becomes r squared, but the extra r is because dx dy is equal to r dr d theta. This is something called the Jacobian, which I will do again when I just do a straight doing the math instead of actually explaining what I'm doing with it. And, okay, this r here is our domain that we're going off of our region. So, to actually get that, we have to look at our original area. That was, we have infinity, 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 negative infinity. Okay? Why did I do it like that? That was wrong and dumb. Okay, that's what it's supposed to look like. Okay, so we have that taken care of. What does this tell us? Well, this domain is from negative infinity to infinity. The second is from negative infinity to infinity. One is in x, one is in y. So, if we take this and move it to polar, r is our radius. So, I'm going to do it like this. R The radius is going to be going from negative infinity to infinity. Then what about our angle? Well, our angle is actually going to be going from 0, aka, well, 0, to pi, or 180. That's because at whatever angle this is, if we do r, it can be negative or positive. So we don't need to make a full circle, only a semicircle, because it can have negative lengths, which then just goes in the other direction. So our new bounds are going to be 0 to pi, infinity to infinity, e to the negative r squared r dr d theta. Now I'm not going to explain how the integral works, or like the integrate. I'm not going to explain the actual method of integration, because that would take way too long, and I'm already going to have to upload this video to YouTube because of the length, so that's not happening. Sorry. So, and then what we actually do is, it's something called a u sub. We say that u is equal to negative r squared du is equal to negative 2r dr, which then we can u sub this in for 0 pi. And we do have to change the bounds of the r one, which is this, but infinity is cool. It just goes in that way. So, actually, if we do u sub this, like we're doing here, u is negative r squared. Therefore, if we put these in there, we're going from negative infinity to infinity. Both of these are technically going to be negative infinity. And that does make a little bit of problem, but I'll fix that in a second. For now, we're not doing that. Instead, we're just going to we're going to keep the r's, but you can kind of see the relation between these. So I'm going to keep the r's, but what we basically end up with is, we solve the u infinity squared infinity, so you do see it's kind of broken up. And we end up with negative 1 over 2. No. Yes, negative 1 over 2. If you're wondering how that came from, I multiplied, because this negative 2 isn't here, I multiply it by negative 2 and negative 1 over 2. They'll cancel out, but then one gets used up, so it leaves the other. E to the negative r e to the u du d theta. This will then go to pi 0 negative 1 over 2. This will then EU, the integral of e to the u is e to the u. So then we have the u from the domain, negative infinity. Now if we actually, this is a little messed up. We're not going to actually use this one. Instead we're going to do the r thing. Instead of the u sub, we're not going to change the bounds and convert back, which will then give us this instead. Which still doesn't work because infinity and negative both go squared to infinity, so then this whole breaks again. So instead we're going to recognize infinity and infinity, because they're squared, it's the same as just going from infinity to infinity. So we're going to split it in half, which requires to multiply by 2, which then gives us negative r squared 0 to infinity d theta. What is this? Well, basically, infinity in there is going to give us 0. then minus what 0 in here gives us, which is 1. So negative 1 times negative 1 is positive 1. Integral pi to 0 d theta is just pi. So that's I squared of pi equals pi. Remember, we want I squared, or I. So we're going to take the principal root, which is basically just saying the positive version of the root. And I say I equal to the square root of pi, which is equal to the integral from infinity of e to the negative x squared dx. And that is the Gaussian integral.